Hello and welcome to another video for pre-calculus. In this video, we are going to discuss about the law of sines. In one of the previous videos, we discussed about solving a right triangle using the trigonometric functions. Now, not just right triangle, we can solve any triangles, even if they are not right triangles, if we know at least one side and two other measures. That means if we know at least one side and two other angles, or two other sides, or one angle and one side, so whatever, but at least we need to know one of the side measure of the one of the side big one of the sides, because if we just have angles, so if we are just given the angles, then we really cannot solve it, because we can construct infinitely many triangles with the same angles if we are not specified the side. So that's why we need to know at least one side. So the triangles which are not right triangles are called oblique triangle. So in order to solve the oblique triangle, we cannot just use the trigonometric functions the way that we did for the right triangles, but we'll use something called the law of sines and cosines, okay? So in this video, we'll discuss about the law of sines, and in the next video, we'll talk about the law of cosines. So we can use the law of sines if we are given angle, angle, side, or two angles, and then side, or angle, side, angle. That means, so this is how we read this, okay? So angle, angle, side means we are given angle, so the next given information should be another angle and then side, or angle, angle, side. So it's not talking about when we say this one, it is angle, angle, and then side. So when you're talking about the second one, it means, so we are given angle, we are given side, and we are given angle. So it could be the side included between the angles, or it could be just the sides that are not included between the angles, okay? So that's the first case. The second case that we have here is a little bit different, and it's very important the way that we read it, because this one says side, side, angle. That means, so we are given side, side, and then this angle, or we are given side, side, and this angle. So in this case, it should not be the angle between the sides or the included angle. So the angle not included between the side means it's the angle that is not formed by those two sides. So if we are given side, this angle and this side, so we cannot use the law of sine. In that case, we have to use the law of cosine, which we'll discuss in the next video. So it's very important the way that you read it. So we are given side, the next given thing is again side, and then angle, okay? So usually this second case, when we are given side, side, and angle, we call it an ambiguous case. In case sometimes we might have that these three cases, okay? So when we are given side, side, angle, in that case, we might not be able to form the triangle based on the given information. So in that case, we have no such triangle, or we have zero triangle. So we cannot make that triangle. There might be a case where we can make one unique triangle, so that is one triangle, or we could have a possibility of two different triangles with this given measurement. So we'll talk more about that in the next few after few slides. And the first one, we are going to look at the example for this one. Okay. So even before we start that, we haven't looked at what the law of sine looks like. So we'll see that here. Okay. So this is the law of sine. So in any triangle A, B, C, so we have a triangle, let's say A, B, and C. And then the way that we write the sides are the sides opposite from angle B is B, the side opposite from angle C is C, the side opposite from angle A is A. So what we have is the ratio of the side and the sine of the angle opposite from it. So A over sine of A, B over sine of B, and C over sine of C. These ratios are equal. And this is what the law of sine is called. This is what the law of sine is, okay? And also we can just take the reciprocal of everything, and then we can also write it in this way. So sine of A over A, sine of B over B, and sine of C over C, and they are equivalent. Either one is okay to use. Now, to prove this, and it's not that hard to prove it, I'm not going to do the whole proof here, but the way, the idea of proving this one is we'll draw a perpendicular from the one of the angle to the opposite side, and then we'll make two right triangles here. And we call this one height, h. Okay, so now if we use this right triangle here and find sine B, that is opposite, which is h, over hypotenuse, which is c, and that gives us h equals c times sine b. And then similarly, if we use the other half of that triangle, or this right triangle, and then find sine of c, then we get opposite side, which is h over b. And then if we solve for h, or if we multiply by b, we get h equals b sine c. Now this is the height, this is the height, it's the same height, so we can say c times sine b equals b times sine c. And then if we divide by bc on both sides, so c cancels out, so we have sine b over b equals sine c over c. So when we drew that perpendicular from angle A to the other side, side BC, we got this relationship. Now, if we do the same thing, if you just repeat the process, if we do draw the perpendicular from B to the other side, then what we are going to get is we are going to get sine C over lowercase c equals sine A over lowercase a. And then if we do from C, we get sine A over A equals sine b over b. And then we have the same, so b equals c, c equals a equals b. So with that combination, when we combine those three equations, this is what we are going to get. Okay, so it's not that hard proof. I'm not going to do the detailed proof here, but you can try doing proving this law of sine. Okay, we're not going to do that in this video. So let's get started. So the first thing, when you're given this information, you're asked to solve the triangle. The first thing you are going to do is you are going to draw the triangle, put the information, and then check whether you can use the law of sine or not. So that's basically what I'm going to do first. So I'll go ahead and draw that triangle. So it doesn't have to be perfect, okay? It doesn't have to be in a scale. We can just draw a random ABC triangle. So angle A is given, which is 53 degrees, and angle B is given, which is 44 degrees, and side B is given, which is this one, 7 centimeters, and then we don't know A and we don't know C, so we'll just write lowercase a and lowercase c. So now, if you look over here, this is angle side. So we are given this angle, so it is angle side. So we have angle side, which means we can use the law of sine. Remember, for law of sine, it should be either angle side, or angle side angle, or it should be side angle. So one of this, if we have one of these cases, then we can use the law of sine. So we basically have this third one, so we can use the law of sine. So what I do first is I'll just write the law of sine and then start solving that. But even before doing that, if you look over here, we know two angles of the triangle. So we can easily find this angle C by subtracting the sum of angle A and B from 180 degree. Let's go ahead and do that first. So angle C equals 180 minus angle A, which is 53 degrees, okay, plus angle B, which is 44 degrees. And if you put this into the calculator, you'll get C equals 83 degrees. That means we have this angle C equals 83 degrees. So we found all the angles. Now all we need to do is we need to find side A and side C. So let's go ahead and write the law of sine. So I'm going to write A over sine A equals B over sine B, and then C over sine C. Now let's put the given information. We don't know lowercase a or the side A, so we just write A over sine A, means angle A is 53 degrees, equals side B is given 7 centimeters. So we'll just write 7 and we'll write the unit at the end. Okay, so sine B is sine 44 degrees. And then side C is unknown, angle C, we just found it, which is 83 degrees. Now, if you look over here, the thing that we are looking for is we are trying to find A and C. Now, if you look at the middle one, both quantities are known here. So what we need to do here is basically we will take the first two and solve for A, and then we'll take the second and third and solve for C. So let's go ahead and take the first two. So when you take the first two, you are solving for A. So basically what I'm going to do is, okay, let me write that down. So A over sine 53 degrees equals 7 over sine 44 degrees. And then if you multiply by sine 53 degrees on both sides, okay? If you multiply by sine 53 degrees on both sides, then we get A equals 7 times sine 53 degrees divided by sine 44 degrees. And then if we put this into the calculator, we'll get A is approximately equals to 8.05 centimeters. So we found the value for A. Now let's take the second and the third one, which gives us C over sine of 83 degrees equals 7 over sine of 44 degrees. Now again, if you multiply by sine 83 degrees on both sides, this one cancels out, so we get C equals 7 times sine 83 degrees divided by sine 44 degrees. And then again, if we put this into the calculator, we get approximately C equals 10 centimeters. So now we found all the sides, and so A equals 8.05 centimeters, and then C equals 10 centimeters. That means we have all the angles and all the sides, so that means we solved this triangle, okay? Now, as I said earlier, when we are given side angle side, we could have an ambiguous case, which means we could have different possibilities here, okay? So if the given angle A is acute, if the given angle A is acute angle, we could have these four possibilities. The first one is when we are given side B and A and angle A is given, if this angle A is smaller than the height of the triangle, then we really cannot form the triangle. That means this is a case where we don't have that triangle because we cannot make that triangle. So we have non-triangle, zero triangle. If A equals height of the triangle, then we can make a triangle here, and that is we can make one triangle. If A is greater than B and also greater than given height, then we can also make a triangle, and that triangle is right here, just one triangle. Now, if A is between A and B, which means A is greater than the height but less than B, then we could have two possible cases. We can make the triangle like this, or we can make the triangle like this. So we could have two possible cases. Those are the four cases when we have A as an acute angle. If A is obtuse angle, then in that case, we could have two cases. Okay, so if A is less than B, we cannot really form the triangle, and if A is greater than B, we can form one triangle. So these are the different possible cases. And then you might be wondering, how do I remember all of this? How do I know whether it is this case or that case? So really, you don't have to remember this. I'll give you a small trick where we can figure out what ambiguous case we have. Okay, so let's see that. So these are the two important parts of that ambiguous case. So the first one, if so when you're given side angle, you are going to use the log sign, you write the log sign, you start solving it, and then eventually when you're solving it, if you get something like this, okay, if you get sine theta greater than 1, so remember the range of sine function, so the range of sine function is between -1 and 1. So if you get sine theta greater than 1, that means it's impossible because the value of sine should be between -1 and 1. So if that is the case, if you get a case, or if your equation ends up getting this thing, okay, sine theta is greater than 1. So if you get sine theta equals 2, or if you get sine theta equals 1.5, or sine theta equals 5, something like that, then in that case, there is no such triangle, or we cannot make the triangle. So that's how we know that this is an ambiguous case. We cannot get a triangle if you get something like this in your equation. You're done with that one. You don't have to solve it because that triangle is not possible. Now the second case is if we get sine theta smaller than 1, okay, less than 1, then this is possible because that's what it should be. Then we could have two things, okay? So the first thing, when you get sine theta less than 1, so for example, if you get sine theta equals 1/2, that means, so sine theta 1/2 means sine is positive in the first quadrant, you have this 30-degree angle, And also sine theta is 1/2 in the second quadrant where you have this 150 degrees. Okay. So this one would lead us to two different angles, the acute angle, which is 30, and the obtuse angle, which is 150 degrees. So now this is what you actually do. So once you get sine theta is less than 1, we'll find both acute and obtuse angle. Okay. And then we'll check. Acute angle, this always works, so we don't have to worry. But the obtuse angle, we have to check. Does that really work? Is it possible to have that angle? So this is how we are going to check. For example, the given angle, because you will be given one of the angles. So for example, the given angle is 40 degrees. Then if you consider this obtuse angle 150 degrees, okay, then what happens when you add these two angles, you are going to get 190 degrees. That means we have three angles in a triangle. When we are just adding two of them, we are getting 190 degrees, which is impossible because the sum of the three angles is 180 degrees. But we are getting the sum of the two angles, which is 190 degrees, so it's already greater than 180 degrees. So this means this is not possible, so only we'll take the acute angle, so that is one possible angle. Sorry, one possible triangle. Now, for example, if that given angle was 10 degrees, okay, then we have 150 degrees as obtuse angle. So now what happens, if you add these two, you get 160 degrees. It's not exceeding 180 degrees. That means this obtuse angle is possible. So that's how you know that obtuse angle is possible, okay? So when you add that obtuse angle with the given angle, if it exceeds 180 degrees, it's not possible. So we just take the acute angle, we have one triangle. If when you add that obtuse angle with the given angle, if it is still less than 180 degrees, then that obtuse angle is possible. So in that case, we'll have two different triangles, one with that acute angle, one with the obtuse angle, and we have to solve both the triangles, okay? So this is how you deal with the ambiguous cases. Now I'll show you example for each of these types, okay? So the first one, always the first thing you do, draw the triangle and check if you can use the law of sine or not. Okay, so let's go ahead and draw that triangle. Again, any random triangle. So let's say this is A, B, and C. So we are given angle B equals 35 degrees. We are given side A 24 and side B 6 centimeters. And then we don't know anything, so this is C, and then we don't know the other angles. Okay, so first we are going to go ahead and write the uh, write the law of sine. Okay, so let's say sine A over A. It doesn't matter if you write this side first. Okay, I'm writing angle first here, so it's the same thing. So sine A over A equals sine B over B equals sine C over C. So angle A is unknown, so I'll just write sine A over side A is 24 equals sine B, which is given 35 degrees. So over side B is given 6 equals sine C is unknown and C is also unknown. So what we need to do here is first we'll find angle A. So once we know angle A, we already know angle B, that means we can find angle C, and then only we'll find side C. Okay, you cannot solve this one without knowing angle A. So that's what you need to really pay attention here, okay? So what we are going to do now is we are going to take these first two, okay, this one, and then try to find angle A. So let's go ahead and do that. So I'll do the cross multiplication here. So 6 sine A equals 24 sine 35 degrees. And then if I divide by 6 on both sides, so I get sine A equals 24 sine 35 degrees over 6. So just to check if this is possible, I'll just put this right hand side into my calculator and make sure that your calculator is in degree mode because the angle measure we are using here is degrees. So when you put that into your calculator, okay, so you can find, you will get sine A is approximately equals to 2.29. Now this is greater than 1, so the value of sine cannot be greater than 1. So which means this triangle is not possible. Okay, with the given information, we cannot draw that triangle. Okay, so this is, you can write no such triangle. See, this is how we know that that triangle does not exist. Now let's look at another example. Let's go ahead and draw the triangle. Again, we'll just say A, B, and C, and then we'll put the given values. So angle A is given 63 degrees. Angle B is not given, C is not given, side A is given 12 centimeters, and then side B is given 9 centimeters, and side C is unknown. So again, let's go ahead and write the law of sine and then put the given values and start solving this one. So we can write sine A, which is sine 63 degrees, okay, over side A, which is 12 centimeters. We'll just write 12 now, and then we'll write the unit at the end. Then sine B is unknown, so we just write sine B over side B is 9 centimeters equals sine C, unknown, we'll write C, and side C is also unknown. So that means we'll find angle B, and then we'll find angle C, and then we'll find side C, okay? So in order to find angle B, we'll take the first two. So sine 63 degrees over 12 equals sine B over 9. So if we multiply by 9 on both sides, so I'm going to go ahead and multiply by 9 on both sides. Okay, so right here, so this 9 cancels out. So we get sine B equals 9 times sine 63 degrees over 12. Now, just to check, you can put this into the calculator, the right hand side, and if you do that, you get 0.668 something. So it means it is possible. Okay, so that means I'm not going to use the decimal value. What I'm going to do is what I'm going to put in the calculator is I'm going to do B equals sine inverse of this whole thing. That way, I can reduce the rounding error. So if I put this into the calculator, I'll get decimal values. If I round them up and then again put it into the calculator, that will increase our error. So in order to avoid the large error, and what I'm going to do is I'll put the whole thing at the end into the calculator. So if we put these into the calculator, this is what we are going to get. So we'll get approximately 41. So B equals 41.9, okay, degrees. Now this is an acute angle. So we will find the obtuse angle. So in order to find the obtuse angle, remember if you know the acute angle, to find the obtuse angle in the second quadrant, we just do 180 minus whatever that acute angle is, okay? So if you do that, so the obtuse angle is 180 minus 41.9. So 180 minus 41.9 degrees. And then if you subtract that, you get 138.1 degrees. So this is the obtuse angle. Now what we need to do is we need to check, is this obtuse angle possible? Okay, so if we check, so we are already given 63 degrees. Now we got that obtuse angle as 138.1, and we still need another angle. Okay, we haven't found angle C. So, but let's go ahead and add this. So if we add this, we get 1. So it is more than 180 degrees. I think it's already, so if you add these two, you're going to get 11, 1, so it's 10, 0, 1, 201. So it's more than 180 degrees. That means this obtuse angle is not possible. Okay, so this is not possible. So the only possible angle is this one. So we have one triangle. That's how we know it. Okay, so now we have angle B. We have angle B equals 41.9. So let me put it here, 41.9 degrees. Now let's go ahead and find angle C. So in order to find angle C, what we are going to do is we are going to do C equals 180 minus angle A plus angle B. Okay, so if we put this into the calculator, we get 75.1 degrees. So we got angle C. Now, in order to find side C, we don't have to, we have to use the law of sine. So we can use this here, the first one and the last one. So the first one and the last one, okay? So sine 63 degrees over 12 equals sine C means 75.1 degrees, 1 degrees over, we don't know C. Now do the cross multiplication. So we get C sine 63 degrees equals 12 sine of 75.1 degrees. And then if you divide by sine 63 degrees on both sides, that gives us C equals, so if you put that into the calculator, we get approximately side C equals 13 centimeters. So side C is approximately 13 centimeter. So we have all the angles, all the sides, we solve the triangle. Now let's look at another example here. Let's go ahead and draw the triangle. So let's say this is A, B, and C. So let's go ahead and write what we are given. So we are given that angle B is 70 degrees, and the side B is 25, side C is 26, and then we don't know A, we don't know angle A and C. So let's go ahead and write the equation. So sine A over side A, which is unknown, equals sine B means sine 70 degrees over side B is 25 equals sine C unknown or over 26. So what we need to do is we cannot find A first because both the quantities here are unknown. So what we are going to do is we are going to use these two and find angle C first. So let's take that and do the cross multiplication. So when we do the cross multiplication, we get 25. So let me use a different color for that. So when I do cross multiplication here, I get 25 sine C equals 26 sine 70 degrees. And if you divide by 25, we get sine C equals 26 sine 70 over 25. And then to find angle C, we take the inverse of this, okay, sine 70 degrees over 25. So now if we put this into the calculator, we get that equals 77.8 degrees approximately. Now we need to find the obtuse triangle. So if you subtract 77.8 from 180 degrees, we get C equals, the other value is 102.2 degrees. So let's go ahead and check if that obtuse angle is possible. Okay, so we have 102.2. The given angle is 70 degrees. And if we add, we get 172.2 degrees, which means it is less than 180 degrees. So this second angle is also possible. Okay, so this angle is also possible. So that means now we have two triangles. So we'll say this is C1 and this is C2. So we have two different triangles now. So we'll solve the first one and then we'll solve the second one. Okay, so the first one, we'll take this one and we'll solve the first triangle. So the triangle 1, so we'll take 77 degrees. So for triangle 1, we are going to write sine A over A equals sine 70 over 25 equals sine 77.8 over C is 26. So now we know angle B and C, so we can find angle A equals, so we can just subtract from 180, 77.8 plus the given angle 70 degree, and that gives us 32.2 degrees. So angle A in the first case is 32.2 degrees. So instead of writing A, I'm going to write, so this is sine 32.2 over A. So all we need to do is from the first one, we just have to find A. So what I'm going to do is I'm going to take these two, do the cross multiplication, and then find A. Okay, so let's go ahead and do that. So if we do the cross multiplication, we get A times sine 70 degrees equals 25 times 32.2 degrees. Now if we divide by sine 70 degrees, sine, sorry, this is sine 70 degrees then we get A equals 25 sine 32.2 divided by sine 70 degrees, and then approximately if we put that into the calculator, we'll get 14.2 centimeters. So for triangle 1, let me write it here. Okay, so for triangle 1, we have side A equals 14.2, side B was given 25, these are centimeters, side C was given 26 centimeters, and then angle A, we got angle A was 32.2 degrees, angle B was given 70 degrees, and angle C, we found that as 77.8 degrees. That was the first possible triangle. Now let's look at the second possible triangle, or I'm going to write triangle 2. Okay, so in that case, we are going to take this as our angle. So if we take 102.2 as angle C, now angle A equals 180 minus 102.2 plus 70 degrees. And then when we put this into the calculator, we are going to get angle A as 7.8 degrees. Now if you write the law of sine, so I have sine 7.8 degrees over A equals sine 70 over 25 equals sine 77.8 over 26. Now to find A, we are going to take this first two equations, do the cross multiplication and find A. So when we do the cross multiplication, we get A sine 70 equals 25 times sine 7.8 divided by sine 70 on both sides. We get A equals, so if we put that into the calculator, approximately we get A equals 3.6 centimeters. So for triangle 2, or the second possible triangle, we have A equals 3.6, B equals, we already have B given, which is 25 centimeters. Okay, this is also centimeters. And then C equals 26 centimeters. Angle A, we found that as 7.8 degrees. Angle B was given 70 degrees, and then angle C was 102.2 degrees. So this is another possible case. So we have two different cases. So this is one of the ambiguous cases. Now let's look at this word problem. This one says a river is flowing north to south. So let's say this is a river. So north to south. Let's say this is the river, okay, flowing from north to south in this direction. Now, a surveyor stands on one side of the river and notices a tree at a bearing of 120 degree on the other side. So let's say the tree is somewhere here. And the surveyor is standing, let's say here. So the bearing of 120 means this is north, so an angle of 120 degrees. This is 120 degrees. And then surveyor walks 400 meters towards south, so he goes south from here. Okay, and then that is 400 meters, and then he looks at the same tree and he has the bearing of 80 degrees. So from here again, so if he's standing here now, this is north, so the angle that we have is this angle, which is 80 degrees. Now what is the width of the river? That's the question. So we need to find the width of the river, means this distance. Let's say this is 90 degrees. Now what we can do now is, let's go ahead and find this angle, because 180 minus 120, so this is 60 degrees. So now in order to find this side, either we need to find this side or this side. So if we use the big triangle, okay, so I'm talking about this big triangle right here. If we use this big triangle, and then let's say this is side A, B, and C. So let's go ahead and find side C, or this side, using the law of sine. So if we use the law, so to find side C, we have to use angle C. So we can write C over, so lowercase c over sine C means 80 degrees equals, we know this side 400 meters over the angle opposite from there, this angle. So we can find the measure of this angle because this is 60, this is 80. When we add them, we get 140 degrees. So that means the angle measure for this angle B is 40 degrees. So we can write sine of 40 degrees. And then if we multiply by sine 80 on both sides, so we get C equals 400 times sine 80 divided by sine 40 degrees. And then if we put this into the calculator, we are going to get C is approximately equals to 612.8 meters. So that is this side C. Okay, so this is 612.8 meters. But our question is to find this width of the river, or this side, okay, or this length. Now what we can do is we can take this triangle. So we can take this triangle, this right triangle right here, and then we can find the width of the river. Okay, so we are finding this side, so I'm going to let this be x. So let me use a different color. I'm going to let this be x. Okay, so this is a right triangle. So we know the hypotenuse, we know this angle. We are trying to find this x. So that means I'm going to use sine. Okay, so sine 60 degrees equals the opposite, which is x, over hypotenuse, which is 612.8. And then if I multiply by 612.8 on both sides, I'll get x equals 612.8 times sine 60 degrees. And then if I put that into the calculator, I'll get 530.7 meters. So that is the width of the river. Now, one more thing, we know that the area of a triangle is given by 1/2 times base times height. So when we know the height of the triangle, or if we have a right triangle, we can use that formula. But if you have any isos, I mean, if you have any oblique triangle that's not a right triangle, then there's a formula to find the area of a triangle. Okay, so if we know two sides of the triangle, and if we know the angle included between those two sides, then we can use this formula to find the area of the triangle. So 1/2 times this side times this side times sine of the included angle. Okay, so it must be the included angle. So for example, if you are given this side, and then this angle, we cannot use this formula. In that case, what we need to do is first we have to find this included angle, and then we can use the formula. So let's go ahead and look at an example here. Always draw the triangle first, just to make sure that you have the right information and you can use that formula. Okay, so I'm going to do that. I'm going to go ahead and draw that triangle. Okay, so let's say this is A, B, and C. So we are given, sorry, this is A, B, and C. It doesn't matter how you draw it. So this is 80 degrees. B means this side, which is 25 centimeters. And C means this side, which is 30 centimeters. And now we can use that formula because we have this side, we have this side, and we have the angle between them. For example, if instead of giving this side, if we were given this side, then we cannot immediately use the formula. Okay, what we have to do is we have to use the log sign, and then we have to find this side, and then only you can use that formula. Or we have to find this angle, and then we can use this side and this side. So it depends on which side is given. Okay, if it does not match up with our formula, if two sides are two sides are given, but if the angle between them is not given, then we need to use the log sign, solve the triangle first, and then only we can use the formula. Okay, so but here we can use the formula. So area equals 1/2. So one of the sides, which is 25, times the other side, which is 30, then sine of 80 degrees. And if we put the whole thing into the calculator, we get area is approximately 369.3, and the side is given in centimeters, so squared centimeters. So that's the area. We'll just do this much for this video. I'll come up with the law of cosine in the next video.